Hello everyone, my name is Adam Jankowski and this video is the first one in the C++ course. We will be learning from scratch, so if you are new to programming, then you found the right place. Throughout the course, I will be explaining thoroughly what is going on in code. There will be a lot to take in, but I will try to be as clear as I can when explaining things. Okay, so let's begin. In order to start programming, we need to download an IDE, Integrated Development Environment, which is plainly speaking a program in which we will write our own programs. Little mindfuck, but that's the way it is. The IDE that we will be using is called CodeBlocks. Let's go ahead and download it from codeblocks.org. We navigate to downloads, download the binary release, and we are interested in the file containing mingw setup in it. We download it from sourceforge.net. We wait a few seconds. And we save the file. The installation process is pretty straightforward. We click next, we agree to the agreement, and we make sure that the type of installation is set to full to avoid any problems. We click next, and we install it. I won't do it because I have already done it before, but you go ahead and install it. See you in a moment. Okay, the program shows up, and in order to create a new project, we hit Create a New Project button. We select console application, and we make sure that C++ language is selected. We give our project a title. I'll go with Tutorial 1. And below it we can specify where to store our project. And then we click Next. And Finish. Okay, nothing has showed up. But if we expand the tree view on the left, we will see our file main.cpp. We double click on it, and this, ladies and gentlemen, is our working environment. We will be writing our code in here. To build our program, we hit the yellow cog icon, and to run it, the green arrow icon. To do it all in one go, we just hit the icon that's next to the arrow. Let's go ahead and do it. And we have just built our first program. It prints hello world by default, and below it there's some useful information. For example, the fact that our process returned 0 means that it hasn't encountered any issues during execution, and if we press any key, the program will close. Okay, so how exactly was our program created? Let's navigate to the folder in which we created our program. We can do it easily by right-clicking somewhere in the text editor and clicking Open Containing Folder button. Our program sits in the bin and debug directory. If we launch it, we will see that it closes immediately. Do not worry, nothing is wrong. The program still does what it was asked for. It prints hello world, and since we didn't tell it to wait, it closes itself. Let's see something interesting. If we try to open it in any notepad, we will see strange things. Why is it? Where is our beautiful sexy code? Well, it hasn't vanished. It has been turned into a binary file. We won't make much sense out of it, but the computer will. Whenever we build our project, what we are essentially doing is sending all our CPP text to a compiler, a special program whose job is to get our C++ code as input and output it as a binary file that can be executed on our computer. So when we hit the arrow button, file.exe is executed, not main CPP. Main CPP is a resource needed to create executable file. So I will recap it now. In order to create a program, we have to write our CPP file and then compile it to get an executable file. If we make any syntax mistakes in the CPP file, the program won't compile and we will get a message in CodeBlocks describing what is the problem. Okay, so let's get to the actual code. In first line, we are including IOStream library. In this way, we are fetching some C++ code from a library. Libraries are files with C or C++ code in them. This one is called input-output stream, and without it, we wouldn't be able to use cout. Before we continue, let me clarify what an input and output is. By input, we mean anything that goes into our program, for example some text from keyboard, and by output, we mean anything that goes out from it. For example, printing hello world to the console. Okay, next line. Using namespace standard. I won't go into detail about it, but basically if we deleted it, we would have to write things this way. It's a bit of a pain, but the program will execute the same. Let's check this out. Everything works fine. I think that using namespace std is more comfortable for us. Let's bring it back. And now the biggest chunk of code, the main function. Whenever our program starts executing, it will search for this function and execute lines of code that are in it. And by in it, I mean between these two curvy brackets. Next line, as you might have guessed, is responsible for printing hello world to our console. Let's analyze this line. Cout is an object of output stream, and these two arrows are called the insertion operator. And hello world is the string that we want to print to our console. So this line basically says, insert hello world string to the output stream, print it to the console. We are not limited to performing only one insertion. We can insert multiple things. After hello world, we insert endline character. If we were to write some additional text after it, it would be displayed in a new line. Actually, let's do it. Let's add some text. I will write hello again. And let's see if it works as we say. Yes, it works. Hello world is printed in the first line and hello again is printed in a new line. That's quite intuitive, but remember that our program is executed from top to bottom and from left to right. That's why the word hello world is displayed before hello again. And one more thing. Cout is defined in the code that we fetched from IOStream library. It is important that the definition of cout is included before we use it. Otherwise, we will be thrown an error. Let's actually check that. We will put include IOStream after we used cout. We'll see what happens. And as expected, we are thrown an error. If we want to use components from different libraries, we must include their libraries first. It is a good practice to include libraries at the beginning of our files. If everything goes okay, our program will return 0. I won't go into detail how functions work yet, but basically every function has to specify what it will return. At the beginning of our main function, we see this int. It stands for integer. And in this context, it means that our main function must return some integer, some value. 0 is returned by default. Don't worry, I will describe functions in detail in a different video. For now, let's not bother about it. Okay, let's print something more interesting to our console. For example, somebody's name, surname and age. I'll go for a female name. Let's say Nuta Godlewska, and she will be 19. Let's write everything down. And let's run the program. Nice, it works, and it's certainly more interesting than simple hello world. Make sure you put semicolon at the end of each line. Without it, you will be thrown an error. Well, that is quite satisfactory. A few minutes ago we couldn't program, and now we can print things to the console. Let's take it one step further and introduce the concept of variables. A variable is a container for data. When we declare a variable, we are allocating memory on our RAM card for it. This is how we create variables in C++. We specify the type of the variable, in our case it's integer, and we give it a name, age. By default, our variable is uninitialized, which means that it is not set to a definite number. Before we can use it, we must assign some value to it. We can do it during the initialization, or we can do it later on. It would be cool if we could save our name and surname as well. We won't use int type of data this time, as it only stores integer numbers. We will use a variable type called string. Remember that text that we want to store must be inside quotation marks. It will look this way. Okay, let's write it in code blocks. Okay, so we have our variables and now we want to print them to the console. First of all, let's delete the old text. And in order to print values from our variables, we do the insertion operator and we will be inserting from our variable to the output stream. Okay, let's see if it works. Well, that's cool. Now if we want to add a new person, we simply overwrite the values stored in our variables. New values will replace the old ones. Let's add John Smith, who is 34 years old. We could just write age equals 34, but let's try to use some other operators. Age currently has 19 stored in it. All we have to do is add 15 to get 34. We write it this way: age equals age plus 15. Now what the heck has just happened there? Let me explain. Age equals means that we want to assign some value to our variable age. So we expect a number on the right side of assignment operator. In age plus 15, we don't assign any value to age. We get the value from age and then add 15 to it. The result of this operation is 34. So in our case, writing age equals age plus 15 means the same as age equals 19 plus 15. 34 is then assigned to variable age. This can be shortened to age plus equals 15. These two lines mean the same. The same rules apply for subtraction, division and multiplication. Okay, now let's check whether we did everything correctly. Let's print the values of our variables once more. And let's see if it works. And it does. Okay, and now the last bit of information for today. Currently our program does its job fine, but it doesn't get any input. Let's change that. We will use input stream called cin. To insert value from variable to output stream, we wrote cout, insertion operator, and the name. We change output stream to input stream, so cout will now be cin. But it still doesn't make much sense. We don't want to insert the value from name to our stream. We want to extract the value from cin to name. the operator is not right. We have to change it so that instead of insertion operator, we'll have an extraction operator. Now it reads, extract the value from cin and put it in our variable name. Let's print the result and see whether we got it right. A random name. Okay, it works. Let's see something interesting. If we separate our input with a space, we'll get a strange result. Cin will only read the first name. Why not the second? And it is because a space is a separator. We told the cin to get the value for our variable name, so it will only take the first continuous string of characters, excluding space. Therefore, the second item will not be stored. Just as we could do multiple insertions with cout, we can do multiple extractions with cin. Let's see the example. Let's run it. And now we expect to get two strings for our variables. So we will separate them with space. The first string Adam will go to the variable name, and the second string Jankowski will go to the variable surname. Yes, it works as we predicted. Now let's improve the looks of it, because a poor random user has no chance of knowing what variable's value are they setting. Let's break our long cin into 3 and let's add a cout before each, describing what values are being set. Now let's copy and paste our couts to get the feedback. And let's run the program. So let's provide some random name, surname and age. And yes, it works! Hooray! If you lasted until now, then you have my congratulations. Some concepts that I talked about today might still be a mystery to you, but let's concentrate on the positive things. Programming can be fun, and the code that we wrote today is not that hard to understand. I encourage you to play a bit with what you have learned today and try to write a small program on your own. That's all for today. Thanks for watching and see you in next videos.